Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about our final year project, which is the title is Smart Plant Monitoring System with SMS Alert. Before we start, I would like to introduce our group member. My name is NURULHIDAYAH binti AHMAD HIDZIR and my partner is Nurul AFIQAH binti AWAL.
The outline for this presentation is introduction, problem statement, objective, methodology, result and discussion, and lastly is conclusion and future recommendation.
For our first subchapter is introduction. The system plant that we use in this project is aquaponic system. Aquaponics is the combination of aquaculture, which is growing fish and other aquatic animals, and hydroponic is growing plants without soil.
The second subchapter is problem statement. For the first problem statement is the world population will have to find a way to produce the greater quantities of food sustainably as the world population continues to grow. Secondly is many countries with small amounts of land available for agriculture are expected to see the large numbers of population growth in the future. And lastly, the current aquaponics system is primarily monitored manually by the user.
The third subchapter is objective. There are three objectives that we can talk about in this project. First, to help the farmer in notifying the problem in the aquaponics system by using SMS. Second, to develop an Internet of Things based on aquaponic monitoring system which measure and displays parameters continuously to the user. And lastly, to build a prototype of an aquaponic system that uses modern technology to monitor important aspects. The next subchapter is methodology. Circuit diagram. The circuit diagram shows all the inputs and the output that are connected to the Arduino Mega. Each input had a buzzer and LED to give an alert to the user. pH sensor was replaced with the connector pin because there is no suitable or similar component as a pH sensor in Fortius. Software Fortius was used to design the circuit diagram. Next is block diagram. In this block diagram, it has input, microcontroller, and output. For the microcontroller, this project used Arduino Mega. It has three inputs for this project. Firstly, the DHT22 sensor. Second, ultrasonic sensor, and lastly, pH sensor. For the output, it also three components that we use, which is LCD I2C, GSM module, and LED and buzzer.
For the project diagram, the donut board was used to replace the PCB board, and all the inputs and outputs except the GSM module have been soldered in this board by using the pin connector. Other than that, the VCC and ground that are connected to the Arduino Mega also have been soldered on this board. The fifth subchapter is result and discussion. This is the hardware for the smart plant monitoring system with SMS Alert. In this project, the fish that we use is the glowfish tetra and the plant that we use is Brazilian spinach. The first graph shows the height of the plant in centimeter within the 4 weeks of monitoring. Based on the graph, the height of the plant was increased every day. The next graph shows the diameter of the leaf in centimeter within the 4 weeks of monitoring. Based on the graph, the diameter of the plant was increased every day. The next graph shows the water level in 4 weeks of monitoring, and the water level was measured by using the ultrasonic sensor. The next graph shows the pH level in 4 weeks of monitoring the tank, and the pH level was measured by using the pH sensor. The graph shows the temperature in 4 weeks monitoring the plants. Based on the graph, it shows that the temperature was in the range between 25 to 30 degrees Celsius. The temperature was also measured by using the DHT22 sensor. The next graph shows the humidity in 4 weeks monitoring the plants. It shows that the humidity was in the range between 60 to 80% and the humidity was also measured by using the DHT22 sensor.
Next is discussion. There are 4 things that we can discuss. First, the system monitors the value of pH, temperature, humidity, and the water level in the tank with the GSM module as the connection between aquaponics system and the smartphone. Second, the data collection showed that the plant in the aquaponic system was increased its leaf, diameter and height. Third, the GSM module will make sure the farmer gets the notification by using the smartphone. And lastly, the user knows the current state of their plant by receiving a SMS.
The subchapter is conclusion and future recommendation. The conclusion for this project is this project had developed an Internet of Things based aquaponics monitoring system, which is by using the GSM module. Next, by using the GSM module, the user got the notification on the SMS about the system. Therefore, the user can be more alert with their plant's condition when get the SMS. Lastly, the GSM module is easy to use as it did not have to connect to internet or Wi-Fi and any apps. It means that the user can get the SMS anywhere without any problem.
Next is future recommendation. For the future recommendation on this project, firstly, to create the application to monitor this system frequently. Second, to create auto pump to clean the water in the tank. Third, to provide the large tank to solve the problem with dissolved oxygen in the tank. And lastly, to use a stick-on thermometer to control the water's temperature. In this project, it has three inputs, which is first, the HT22 sensor to measure the temperature and humidity. Second, pH sensor to measure acidity or alkalinity of the water. And lastly, ultrasonic sensor to measure the distance of water level. This project also has three outputs. Firstly, LCD I2C to display the value of parameters. Secondly, LED and buzzer that will turn on if the value of parameter is out of the range. And lastly, GSM module to send the notification of the SMS to the user.
This is our project, which is Smart Plant Monitoring System with SMS Alert. The process in this project is all the inputs, the HT22 sensor, pH sensor and ultrasonic sensor will scan and send the data to the Arduino Mega and GSM module. After that, all the data will be displayed on the LCD I2C. Then, the buzzer and LED of every sensor will be turned on if the data is more or less than the average value. The function of these buzzers and LED are for the farmers to detect the condition of their plants. Lastly, all the data will be sent the notification of the data through the SMS. Therefore, the users can be more alert with the condition of their plants easily from anywhere.